Hello, everybody. My name is Xiaoyu Zhang. I'm from the University of California, Davis. Today, I will present our work about a visual analytics approach for the diagnosis of heterogeneous and multidimensional machine maintenance data. So, I would like to start my presentation today with a simple example. Suppose we have a data set worthy of $1 million. It records all the machine maintenance logs of a company for over 10 years. If the machine maintenance knowledge embedded in this dataset can be fully uncovered, it would save a great amount of machine maintenance cost for this company. So the maintainers of this company try to approach this dataset, but they find that it is far too big for them to efficiently profile it. Then they turn to the data analysts of this company. The data analysts have more knowledge about how to deal with relatively bigger data set. However, they don't have enough domain knowledge to fully understand the content of this data set. Now, if there is one person who can build a bridge between these two parts of the people by using some visualization tools, it will become a win-win situation. So actually, this is what we aim to achieve with our work and the role we consider ourselves to play. More specifically, we have developed a visualization dashboard as well as multiple algorithms to support effective exploration of the knowledge from this dataset. Before I dive into more details about our system, I would like to tell you a bit more about the dataset we used and the challenges coming with it. In this dataset, each row represents one maintenance event or one breakdown with multiple fields, such as the date and the location of the maintenance, the description of it, and the labor hours or cost of it. So it tends to be a high dimensional. Actually, there are more than 270 fields stored in the log. And as such kind of record accumulates, the scale of the dataset also increases rapidly. For our dataset, there are more than 20,000 records to process. It is hard to directly show you the entire dataset here, but let's just have a closer look at this small piece of the dataset. As you can see, there are at least 3 types of the data in the dataset. So the description can be considered as text data, and asset number and building can be considered as categorical data. Actual labor hours and actual labor cost are numerical data. So apart from the different types of the data, there are also misspelling and data missing problem in this data set. And there are also a lot of abbreviations and terms in the data set. So in summary, the 3 characteristics of the data set bring about 3 major challenges for our project. They are the large scale and multi-dimensionality of the data set, and the heterogeneous nature of it, as well as the data flaws coming with them. So in the next several slides, I will show you how we come up with effective and intuitive ways to handle these 3 different challenges. We deal with the data flaws with some pre-processing steps, combining the classical natural language processing algorithms and the manual data cleaning. So I will skip this part and reserve more time for the second challenge, which is the large scale and multi-dimensionality of the dataset. And the basic idea of handling this challenge is to take use of the dimensionality reduction and clustering algorithms to project the dataset onto a 2D space and provide an interactive overview for the users to explore the dataset. So as you can see here, the top 3 panels are the 3 2D projection views we provide for the three different types of the data in the dataset. For each projection view, we draw one hexagon plot to show the distribution of this part of the data. In this hexagon plot, each hexagon represents one or multiple rows in the original dataset. And we use color to encode the default cluster we assign to this hexagon. So for example, you can see there is a big group of blue hexagon. They are corresponding to the default cluster with the default hex, code, room, and pop. Finally, we use the opacity of the hexagon to represent the density of the data located in this area. You might notice that there is only one colored panel among three of them. That is because we only have limited number of color to use, and there are clusters with the same color across different panels. So for example, there is a blue cluster for every panel. For text data, it is here. And for the categorical data, it is here. And for the numerical data, it is here. And to eliminate any potential confusion caused by this, we only show one active panel each time. To support different levels of details exploration of the dataset, we design several ways of interaction. For example, if the users are interested in a specific part of the dataset, they can zoom in to have a closer look at it. And if they zoom in close enough, the hexagon plot will turn to the scatter plot, where each dot represents exactly one row in the dataset, and the user can now hover over the dot they're interested in to inspect the detailed content inside that row. To help the user inspect the part of the data they are interested in, we also provide three different ways for them to select a subset of the dataset. For example, they can select one hexagon or dot in the scatter plot, or select one cluster, and even using the brush tool to select a customized area they are interested in. And after that, we provide several Boolean operations for them to combine multiple selections. Again, to help them build a connection among the three data types, if the user selects one group of data from one of the three panels, the corresponding hexagons or dots in the other two will also be highlighted. Okay, so now let's move on to the last challenge, which is the heterogeneous nature of the dataset. To solve this problem, we use different algorithms for different types of the data and design several interactions for users to build connections among them. If you look at our dashboard vertically, you will find that for each type of the data, we design two panels for them. The projection view on the top and one special supplementary view exactly below it. I will explain the specific algorithm and visualization we choose for each type of the data one by one. Let's start with the text data. For the text data, we present it with a keyword frequency plot. When no cluster in the projection view is selected, we will see the most frequent keywords in the entire dataset. When we select a specific cluster, the keyword frequency plot is updated to show the top keywords in this cluster as well as the overall dataset. For example, if we select this brown cluster in the projection view, the gray bars will show the global frequency of the top keywords, and the brown bars will show the frequency of the corresponding keywords in this selected brown cluster. Now let's move on to the numerical data. We use the CCPC algorithm to analyze the numerical data and supplement the projection view with a feature contribution panel. which we can examine by hovering over the corresponding square in the heat map and check the contribution of each feature towards the separation of the selected cluster. For example, for this blue cluster in the projection view, we find that the actual labor hours contribute a lot to the separation of it against the rest of the data in the dataset. Finally, let's have a look at the categorical data. For categorical data, we developed a new contrastive learning method called CCMCA for it, namely contrasting cluster in multiple correspondence analysis. It is capable of effectively highlighting the unique features of a cluster and producing a new projection best separating the data objects from this cluster against the others. We provide two plots in the category contribution panel to visualize the analysis result of CCMCA. In the cloud of individuals on the left, each dot represents a row in the original dataset, or we can say a maintenance log. In the cloud of categories on the right, each dot represents a specific value of a certain categorical feature. These two plots share roughly the same shape of layout. To look for category values that contribute more to a selected cluster, this green cluster, for example, we look for dots from the cloud of categories, located at roughly the same area as the green dots, located in the cloud of individuals. So we can see that for this green cluster, the equipment type GG, the supervisor ID S38, S39, the building number 423, and the information type building contribute more to the separation of it. Now I would like to demonstrate how our system operates as a whole with a use case scenario. After loading the dataset into the system, we see the dimensionality reduction and clustering result for all three types of the data. Currently, the categorical data panel is activated. The clusters are represented with different colors, and we provide default tags for them based on the problem and solution descriptions in the logs. We can click on one hexagon, cluster, or brush an area in the projection view to select the data and see their correlation with the other two data types. We can also check the contribution of each category to the current cluster by examining the cloud of individuals and the cloud of categories. To look for category values that contribute more to a selected cluster, we look for dots from the cloud of categories, located at roughly the same area as the colored dots in the cloud of individuals. We achieve this through a new contrastive learning method called contrasting clusters in multiple corresponding analysis, or CCMCA, that we mentioned just now. The numerical data panel is supplemented with a feature contribution panel, which we can examine by hovering over the corresponding square in the heat map. Finally, the text data panel is supplemented by a keyword frequency plot. When no cluster is selected, we see the distribution of keywords in the entire dataset. When we select a specific cluster, the keyword frequency plot is updated to show the top keywords from this cluster in contrast to the overall dataset. To evaluate the effectiveness and usefulness of our prototype system, we conducted a semi-structured, open-ended expert review with 3 domain experts in the machine maintenance log analysis. Because of the pandemic, we follow the remote pair analytics paradigm for our user study. In another word, the study was conducted using a video conference setup, where the experimenter controlled the tool via screen sharing. At the same time, the expert remotely observed the visualizations and suggested filters, queries, and interactions. According to the feedback from our domain experts, Our system is highly reasonable and useful for discovering the valuable information from the dataset. Um, in particular, they like the brushing tool and the linkings because they think they are intuitive and useful. However, at the same time, all three of the domain experts felt that this tool requires relatively long learning curve to understand, especially for understanding the hexagon plot. So we will try to optimize and simplify our hexagon plot for better understanding in our next iteration of development. To wrap up my presentation today, we developed a visual analytics approach to deal with the three major challenges coming with the machine maintenance log dataset. We combined the machine and human power with several pre-processing steps to solve the data floss problem. And for the large scale and multidimensionality problem of the dataset, we take use of the latest dimensionality reduction and clustering algorithms. At the same time, we design several interactions to support multiple levels of detailed exploration. Finally, for the heterogeneous nature of the dataset, we choose separated algorithms and visualizations for the three different types of the data. In particular, we developed this new algorithm called CCMCA for the categorical data to support better understanding of the contribution of each features to the separation of a selected cluster. Finally, I would like to thank my brilliant co-authors, the domain experts who participated in our expert review, the anonymous reviewers of this paper, and most importantly, the sponsors of this project. That ends my presentation today, and I'm ready to take questions.